Hello everybody and welcome. My name is Samer Aoudi, and in this video I will try to recap what I did in my CSF3203 Intrusion Detection and Ethical Hacking course. So a very important disclaimer for my subscribers. This is specific to my college course CSF3203. It's specific to my students who are about to take the final exam. So other than the fact that it's specific, it also is a recap, so it might seem a little rushed. Okay, we have a lot to cover, so let us get started. Okay, so an ethical hacker is a hacker in terms of the things that they do. So we do perform hacking activities. However, what differs is the condition. So we do have permission and also the purpose, the goal. So ethical hackers do things defensively as opposed to offensively. Ethical hacking falls under the security testing activity. So basically a security test is a comprehensive test. Under it we have subsets, things like security audits, vulnerability assessments, penetration testing. So ethical hacking might be exactly what penetration testing is. So they are equivalent. So penetration testing also, we can say that part of it is vulnerability assessment. So if you recall the phases of penetration testing methodology, at one point we perform vulnerability analysis or assessment. So when we say vulnerability assessment, we're looking specifically for weaknesses in our systems. However, when you define penetration testing, please remember it's always important to say that we are attacking the system. We are simulating an actual attack. However, as I mentioned before, for defensive purposes and with permission. When we talk about penetration testing, there are a few teams, but here in our course we covered two specific teams. The blue teams, blue is defensive or the defense team, and the red team who is the offense or the attack team. So basically, if you're doing a competition, a standard competition in our industry, which is a CTF or capture the flag would be something that the blue team would hide, let's say, and the red team is trying to find it. This is a terminology that we borrow from military, and they do something similar, but of course physically and sometimes literally. Okay, so when we as the red team perform penetration testing, discover vulnerabilities, then we need to report it, and the blue team's responsibility is to fix it. So as part of the penetration testing report, if you recall, in the project I asked you to do or provide fix recommendations for all the vulnerabilities that you discovered in your target. So this should be, at this point in the course, something that you know. Our penetration testing tools usually involve a tiger box, a toolbox of many security tools, and the one that we're using in our course is a Linux distribution called Kali Linux. So you might have seen or used a lot of the tools that are available in Kali Linux. I am also demonstrating all the tools in a series on this channel. In fact, some of the tools that I already demonstrated, like under vulnerability analysis and fuzzing tools, I use some scripts. So scripts are programs. They're a set of instructions written in a programming language. And some of my subscribers asked me, should they learn Python? And the answer was absolutely. It's a very good language, and when you as a penetration tester or as a security person know how to program and write your own script, then you become at a higher, more professional level than opposed to what we call a script kiddie, who just uses the available scripts online as they are, and sometimes without understanding. So few concepts that you will see in the next couple of slides. Daisy chaining is when we perform our activities, whatever they are, ethical hacking or actual hacking, and then we backtrack in an attempt to hide what we did. So the purpose of daisy chaining is not to get caught, or if you remember the security function, the detection, we don't want to be detected. So some hackers show off that we hacked this company or that system, but really the sinister hackers don't do it to show off. They do it for, you know, deeper reasons, and of course they perform daisy chaining so that they're not detected, they're easily back in the system whenever they want. So I mentioned vulnerability. A vulnerability is a weakness in a system. A threat is something or someone that compromises your security. For example, a hacker is a threat, so that is someone, but also a fire is a threat. Remember, a threat has a threat actor that compromises the security. And if you also recall, we said that employees, the internal threat for a company, because employees, whether knowingly and intentionally, because they're angry, do something, or unknowingly, unintentionally, they make a mistake and that causes, for example, to delete something or to affect the integrity of information. So then exploit is basically an attempt to breach the system. I might actually, let me here retract a little bit. I prefer to use, you see, if somebody attacks me, the attack may be successful or not. So the attack is the attempt, and therefore the exploit is the breach. Okay, so I stand corrected here. Again, an attack is an attempt because it may be successful or not. And then if it is successful, it leads to an actual exploit, and that is a breach in the system. What we usually attack or exploit is a vulnerability. Remember that, okay? So if you recall, in your project, you discovered vulnerabilities, and then the next step was to choose some of these vulnerabilities and attack them. If you did it successfully, then you have an exploit. So a 0 day is a very important concept. A 0 day is a threat that is has been unknown. It could have been unknown for a year, 2, 3 years, 1 day, 1 hour, and then at some point the security community becomes aware of this vulnerability. So that is the 0 day. Before that, it has been unknown. When we talk about hackers, we classify them using different classifications. So you might look at the intention, whether they do things intentionally or unintentionally, whether they do things with permission or without permission. We look at their professional level, so whether they're experts or still amateurs. And we see here some of these definitions. So a script kiddie, I already mentioned. Cyber terrorist is just another level where you attack national interests. And some of the attacks that we have seen in recent years were state-sponsored. That means the government of a certain nation sponsor the group of hackers who perform attacks against other countries. I think you all know what the impact of hacking is. Some of us have seen it firsthand. Some organizations definitely in recent years have seen the impact of hacking is definitely negative, and it ranges from sometimes the lack of availability of resources. Sometimes it's blackmail and it involves financial losses. If you remember in the WannaCry malware attack and other recent ransomware attacks, the company's resources and systems were encrypted, and the way to unencrypt it is to pay the hacker a certain amount of money. So again, expertise level, we have the expert, the professional who know how to create their script. We have the novices or the script kiddies, sometimes referred to as packet monkeys. One classification is to use the color coding, which is not quite used in the industry these days in the same way that you see here in our textbook. So we have the black hat versus the white hat, where we say the black hats are, the guys who perform hacking offensively, versus white hats where they perform it defensively. So again, this is not widely used anymore. In fact, maybe it's not used because we say black hats are the best of the best. But again, we have a curriculum and a textbook that we're following here. So the gray hats sometimes switch sides. So sometimes they are on the offensive, sometimes they are in the defensive side. And of course, suicide hackers are those who don't care if they get caught, so they end up just doing whatever they do as a reaction to something or to avenge something. And I'm not gonna go over more details on that. So this is basically just the classification as explained earlier. The role of an ethical hacker, this is very important. So why do we do what hackers do? Why can't we do it in another test? Why can't we just simply run an automated vulnerability assessment and that's it, discover vulnerabilities? All these questions are valid, and the answer to that is that when we perform hacking activities defensively, of course, and with permission, we're trying to answer three important questions. What can the attacker see on the target system that they breached? What can they do now that they breached our system? And the final question, can we detect, can we know that somebody has been in our system? The only way to answer these three questions is to become a hacker and do what the hacker does. Okay, so this is very important. Always put it in the back of your mind when you're trying to answer questions about ethical hacking and why we need it, or penetration testing, of course. What kind of knowledge you need to have? An extended knowledge in computing, the different platforms, the different tools. You cannot say I'm only proficient in Windows, but what if the system is Unix, Linux, AS400, something else? And of course, many tools available. Even in our own TigerBox Kali Linux, we have over 100 tools. What additional skills should you have? Again, as a penetration tester, you will be working with different clients, performing penetration testing for them. So in the beginning, as you will see in the methodology, you have to agree on rules of engagement, and this involves communication skills, understanding exactly the scope of your work, what is allowed, what is not allowed. And of course, you must understand the legal implication of your work, which is something that I will explain shortly. So legal considerations become very important. Many activities that we perform as ethical hackers are or may be considered illegal. So you must know. And when you don't know, there is a very simple rule: do not do it. Okay? So please, this is very important. We have performed all our lab activities in a controlled environment, and whatever we did, I just simply say don't do it outside the lab environment. And I taught you how to create your own lab environment, and you can test as much as you want. Without permission, without explicit permission, you would be on the wrong side of the law, and you don't want that. So any of that can be considered illegal. These are high-level categories. So when you access a computer without permission, when you destroy data or change it, when you copy without permission, when you send somebody worms, viruses. It's interestingly enough, every time we do the malware lab, students ask me, oh, how do I send this? How do I do that? This semester, actually, I also showed you a distribution method for our malware. And I hope that none of you will be trying any of that, even on friends. So please do not do it. A list of don'ts. I'm not gonna read it. This is for you to read and study. When you commit cybercrime or any crime for that matter, there are three core components. When they exist together, then the crime is more likely to happen. So the first one is the means. Do you have the skills, the means, the abilities to do that crime? And the second one is a motive. Do you have a reason to do it? And the third one is an opportunity. You might have the means, you might have the motive, but there is no opportunity. In our case, maybe the system is very secure, is as simple as that. So again, having means and motive and opportunity and would probably be conducive of cybercrime or any crime. In the UAE, we have the cybercrime law number 5 of 2012. We have seen it. We have seen or read some of the articles available. There are 51 articles available in this cyber law. For my students here in the UAE, you definitely need to be familiar with the law. You need to be familiar with the amendments in the law. But of course, in the exam, I don't think, any instructor would be asking, what is this law number 21, or sorry, article number 21. It is available in the Ministry of Justice, on the Ministry of Justice website. You can refer to it and read it. So, penetration testing. I talked about testing. I talked about the subset. So you can see here the big circle, the blue circle is security test. Within it, you have penetration test. Within penetration test, we might do something related to discovering vulnerabilities. So we call it vulnerability scanning. A security audit is a type of a security test again, so it falls under security testing. And basically, when we do an audit, we're checking, we're doing a walkthrough of what we have, our policies, our standards, our procedures. So again, it's a valid type of test. It's not a penetration test because it's only involves maybe observations or walkthroughs, asking questions, while a penetration test is performing hacking activities. So penetration testing is needed for really many reasons. You will see here few of them. So number one is to identify what threats and threat actors are facing our organizational information assets. Then using that information, we can prioritize, because the reality is we have a budget and we prioritize in order to say, okay, if I have 100,000 dirhams to spend and I have 10 vulnerabilities or threats that I need to take care of, but the 100,000 dirhams can cover a 5 out of those 10, then the prioritization comes in handy. Then you can spend it as number 1, number 2, number 3. Of course, this is simplistic, but just to show you what it means. Penetration testing allows us to test the security controls that we have. Are they working? Are they not working? And of course, to maintain the security whenever changes take place, whenever we upgrade our systems, whenever we use new systems. And trust me, there are a lot of statistics on this. The return on security investment has been proven. Maybe 5, 6, 7 years ago, if you ask the senior management to invest in security, they'll tell you, no, what is this? It's enough what we have. We have a firewall, we have, username and password, it's enough. But then they realized after a breach, after being attacked and having to spend millions of dollars, they say, oh, I should have done that. So definitely there is a very good return on investment here. Sometimes we do it because we have to do it, because the government or the standards, the industry regulation tell us to do it. So no option. If you want to operate in that industry or that country, you must have a proof that you have done penetration testing. And of course, provide an approach where we can identify vulnerabilities and prevent exploitations in the future. We have a lot of methodologies out there. So the OSTEM methodology is an example. It's a comprehensive methodology. You can find more simplified methodologies that focus on the tasks rather than the processes, like for example 0.59, which is a single web page that you can visit, and you have something specific to a domain, for example the web security penetration testing. The methodology for that is OWASP, that you will see it in another course, the web application security course. In our course, we are adopting the SANS penetration testing methodology, and basically I'm gonna go into that in the next few moments. Before I do that, let me just remind you, when we differentiate a pen test or an ethical hacker from a hacker, okay, there are two main differentiations. Number one is the goal. So offensive versus defensive, where the goal of a pen tester is to protect versus the goal of a hacker is to, whatever, gain financial gain or just breach the system to show off and so on. And the second one is permission. So we always have permission while the hacker don't. So there are few slides that come after that cover these different phases. I put them like that so that you understand what we do, what the hackers do, and where we intersect, where we do similar things. So you can see on the left the SANS penetration testing methodology adapted into our course, and you can see the red on the right is the hacking. Whenever you see a gray area, it means it's an activity that this side or that side doesn't do. So number one is planning and preparation. This is where we talk to our client, we agree on things, including the rules of engagement, ROE, and what we are allowed to do, what we are not allowed to do, what time are we going to do the penetration test, what systems are included in the penetration test, the scope. All of that we do. The hacker doesn't plan formally, right? Maybe they're the good hackers, do some planning, but it's different kind of planning. Number two is basically when we start collecting information. So in my Kali Linux security tools series, I already finished, I can't remember, around 50 tools or more just for collecting information about our target. So information gathering or reconnaissance is the name that we use for that. After you collect information, you go into using that information to collect more specific information, which is the vulnerabilities. What vulnerabilities are present in our target system? So this is called vulnerability detection, but also we may call it scanning, because if our course is about network penetration testing, then we must scan our network, as I will explain later. The next step, with all that information, you know the vulnerabilities, then you want to try and gain access. We call it the penetration attempt. Usually hackers would want, the good ones would want to maintain access, leave a backdoor so that they can re-enter the system undetected next time. A penetration tester might do post exploitation activities, but only to make a point and for demonstration purposes only. Then this is the most important for a penetration tester. All your work is great and nice, but it's all about the report. So you must analyze what you did. You must present it in a professional way to your client so that they understand. When I say in a professional way, if you remember, I just mentioned that one of the one of the benefits of penetration testing is to be able to comply with governments and industry regulation. Well, sometimes the report must follow these regulations. That means the format of the report is as per, let's say, the health industry or the credit card industry, okay? And at the end, the penetration tester must clean up so that the system is back to its normal operational and data and behavior and everything, while a hacker does something that may seem like a cleaning up, but it's not. They're doing daisy chaining, clearing their tracks. So this is it for the comparison. I'm not gonna go over this again unless I forgot something. Yeah, when we say reconnaissance or information gathering, we either do it passively, meaning without direct interaction with our target, or we do it actively, meaning we directly interact with our target. And passive usually does not lead straight back to us, and active definitely easily traceable back to us. So remember that when you perform your reconnaissance activities. I think I've covered most of these, if not everything in here. So yeah, okay. So let's talk a little bit about the penetration testing models. Again, this is not to be confused with white hats, black hats that I mentioned before. These are the models. So we have a clear box model or a white box model. I prefer clear box, but again, we're using our textbook here and curriculum. Clear is really tells you that you can see through, right? And what it means here is that when you use the white box model, you as a penetration tester have enough information from your client about your target system. So in other words, you don't need to perform reconnaissance because they give you all the information. A black box model is the opposite. It's not clear. You don't see what you're about to attack. So definitely you need to perform your own reconnaissance. Each one has its advantage and disadvantage. The black box model mimics exactly the hacker because the hacker doesn't have any information. So again, depending on the time that you have, depending on the situation, depending on the agreement you had in the planning phase, and the rules of engagement that you signed on, you might choose either one of them or a hybrid of them, which is called the gray box model. There are different penetration testing type. Our course falls under the network penetration testing. You can perform penetration testing on applications, can be web applications or mobile application. You can perform penetration testing on people, or of course we call it social engineering. We don't really call it penetration testing of people. Physical penetration testing again refers to doing physical reconnaissance, physical exploitation or attacks to the location of our target. So this covers the first two chapters, if I'm not mistaken, of the course, and now this is the networking chapter. So in the networking chapter, we said that we are following the TCP IP stack as opposed to the OSI model. And if you recall, we said that there are some security implications, some things that the hackers can exploit at the different layers. So we call it a stack because it's a data structure in computing that looks like a stack of plates. Meaning, if you have 4 plates, the bottom one is the one that provides the foundation. Then you have something on top of it, and then on top of it. So the top one, in this case, the application layer, needs the transport layer, which needs the internet layer, which needs the network layer. And on each layer, we have different protocols and we have different tasks and things that we do. So each layer has its own responsibilities. We said in our course the least one that we're using is the network layer. This is the network interface. This is where we get a connection. And here we have the Ethernet protocol, and basically the piece of information relevant to our course would be the MAC address. Now that I have a connection, on top of that I have the internet layer. The internet layer provides addressing. If you want to call me, you need to have my phone number. If computer wants to communicate with another computer, it needs to have the IP address. Okay, so the internet layer provides mechanism for addressing, among other things. On top of that, you have the transport layer. The transport layer provides some segmentation, multiplexing, and packaging responsibilities or services. And on this layer we have, or in this layer we have 2 protocols only. One of them we use, either the TCP protocol or the UDP protocol. And then on top we have the application layer. The application layer basically is the layer closest to us people. So when I use a web browser, the web browser is the application that talks to another application, which is the web server on another computer. On this layer, the application layer, I have many protocols. Okay, the other 3 layers we don't have a lot. So the Ethernet protocol at the bottom, the internet protocol or IP in the internet layer, plus the ICMP protocol at this layer. The transport layer, TCP or UDP, almost everything else, if you must guess, would be application layer. But of course, there are exceptions. This is a mapping to the OSI model. Again, I'm not gonna just go over it for now. Let me just see if I missed anything when I discussed these layers. This is an example showing you the flow of data. So think of the data starting from the simple example of you browsing the internet, the web, right? So you open a browser, which is your application, and then you type in something like google.com. That's your data. You want the Google web page or home page. So the transport layer in this case would be taking your information from the application layer and packaging it, doing some segmentation, and then it goes down, adds some additional header at the internet layer, which is in this case would be the IP address, of course, and then it goes through the network over the wires to the other side, and then it gets unpackaged and it goes to the application on that side, which in this case would be the web server. These are some of the common application layer protocols, and in the next few slides there are examples of each, but because this is a revision, I'm not gonna go over that. So HTTP and HTTPS are the web protocols. S is for secure. Basically the data would be encrypted. So these are ports 80 and port 443 consecutively. FTP is the file transfer protocol. SMTP is one of the mail protocols. There are others like IMAP and POP3. SNMP is for network management. SSH and Telnet are related because they allow you remote access. However, Telnet is clear text, no encryption, while SSH is the encrypted version, if you will. IRC is for text communication. It stands for Internet Relay Chat. With HTTP, there are methods that we use. Again, in the reconnaissance chapter, they are covered in more details, so I'm gonna skip them for now. The difference between SMTP and IMAP is how we handle the message, whether we keep a copy and forward. So again, you can read this on your own. The transport layer, as I mentioned, is responsible for segmentation, multiplexing, and other responsibilities as well. But the main thing I want to discuss here is the difference between TCP and UDP. TCP is more common, probably. We use it a lot more because it is connection oriented. And if you recall, we establish a connection using the three-way handshake. And the main objective of TCP is reliability. That means I don't want errors. I do have flow control. I have order. And if I miss something or an error happens, I will tell you, stop the communication, please resend me, because this is important. UDP is different. I don't care about any of that stuff. It's a connectionless protocol, so there is no need to establish a connection. There is no three-way handshake here. And of course, it's a different objective. The objective is speed, reduce latency. So we see it more commonly in things like streaming, media streaming. And if you notice, sometimes when you're doing media streaming, the quality goes down. What does it mean when the quality of the video goes down? It means you lost a lot of packets, but because there is no error control and flow control, then the UDP says, okay, continue, no problem. Okay, so you can see between the different uses and the different features of these protocols, we may have TCP. Let's say if you want to send a message or you want to access a web page, versus using a UDP when you're streaming something or you're doing voice over IP. The famous, Zoom sentence these days, can you hear me now, right? So it's all about losing those data packets without double checking. This is the TCP header. It's important. So we can see here, it's organized in a 32-bit structure. So from the 0 to 32, the first 16 bits are the source port. The second 16 bits are the destination port. So if the IP address is the logical address of your computer, the port is the logical address within a computer pointing to which program on your computer is taking care of that communication. So for example, it can be a random port or it can be a specific port. If you're a service and you want your clients to find you, then you must be available on the same number every time, right? So for example, port 80 is always dedicated for web traffic and port 443. So when your client simply asks for your homepage, they don't need to say, port 80. No, it goes without saying, it's default. Okay, but of course we can change these values if we need to. The sequence number is used for flow control. So there is a sequence number 1, 2, 3, 4. Of course, it's not 1, 2, 3, 4, but just to get an idea. Acknowledgement is also used for flow checking. So when you receive something, you say, I received it, acknowledgement. And the next important item that I want to discuss are the flags right here. So let's go to the flags and see them. And this is the three-way handshake. The three-way handshake, remember, it happens in a connection-oriented protocol called TCP. It doesn't happen in the connectionless one called UDP. And you see here the flags, so you can see here that it involves 3 steps. Step 1, the first computer tells the second computer, hey, I would like to establish a connection using the SYN flag. The other computer would acknowledge, remember everything must be acknowledged in TCP, and then would say, okay, me too, I am ready to establish a connection. Then the third step is where the first computer say, acknowledge to the SYN of the second computer. And the sequence numbers are used in this example to show a flow control. We terminate a session in the same way in the TCP protocol. So I would send a finish. Okay, I acknowledge that you want to finish the connection or terminate it, and I also want to terminate the connection. Okay, I also acknowledge that you want to terminate it. So I mentioned then SYN, FIN, and ACK. There are few flags available in TCP. Remember some of the trick questions I asked you in the practical exam related to the TCP flags. So if you have something UDP and I ask you what are the TCP flags, you don't need to open Wireshark and check it. You simply say, well, this is UDP, therefore it doesn't have TCP flags. So let's go over them very quickly. SYN is to start a connection. Usually the abbreviation for synchronize, and the 3-letter abbreviation is SYN. The 1-letter abbreviation is S. Acknowledge, to acknowledge something that you received. ACK, and the 1 letter is A. Remember, sometimes we send a request and we get back an SA, meaning a SYN ACK, or an RA, meaning a reset ACK. Push is to tell the party, the receiving party, not to buffer the packets. So push or PSH or the letter P. Urgent or URG or the letter U, meaning prioritize this packet over other packets. So it becomes like a VIP packet. Reset or RST or R is to say, hey, there's nothing to see here. You usually see reset when you send a SYN to a port, but there is nothing listening on that port. Also, we see it when you, if you remember in the nmap null scan, when you send no flags to an open port that has a service running on it, you get an RA back. So it's good to refer to what we did practically against what we learned in the theory. FIN is to finish or terminate a connection. So these are the main flags, and then sometimes you see other flags related to network congestion. You have the ECE, which says that there is an explicit congestion notification. I am capable of ECN, and the CWR for congestion windows reduced is to indicate that the ECE is set. So this is used when there is some issues in the network. So what about security? Our course is security. All of this talk, all of this understanding of network fundamentals is to really get to the security part. So hackers try to exploit the different layers, try to steal data from the different layers. And there are 3 main areas specific to the transport layer and to the TCP. So you can manipulate the TCP flags in your scans to trick the target to give information about its ports, to bypass firewalls and intrusion detection systems. You can manipulate the sequence number and perform man-in-the-middle attack, and replay attack, session hijacking, and so on. And of course, you can get very useful information from the source and destination port numbers. So if I see port 80 and I know that there is a web service running on that computer. This is important, knowing the port numbers. We've used these a lot, so it's very important. Unfortunately, you must memorize these ports to be able to answer some of the questions. So I might ask you, for example, to see if the Gopher service is available on a target. Well, in this case, it is port 70, and in my scan, I would check, let's say if I'm using Nmap, I would check the P option with the 70 value. Okay, so please remember that. There are 65,536 ports on computers. Some of them are dedicated. They're called the well-known ports from 0 to 1023. Others are registered and used when we need it. Some of them are dynamic and used randomly by clients usually. So your web browser would pick up a random dynamic IP address from the computer if it wants to communicate with a web server. A combination of the IP address and the port would tell you basically where the communication is going, because the IP address is the address of the computer and the port address is the address of the service on that computer. So a combination of the source IP and source port is called a socket, and the combination of destination IP and destination port is another socket. Okay, so remember this term, socket. The UDP header is much simpler than the TCP header. Basically, we do have the source and destination port. We have the length of the header itself, the data, and we might optionally use the checksum for error checking. Optionally, remember, because UDP has no mandate to do error control or flow control. So therefore, UDP is focused on speed and reduced latencies. These are some of the protocols that use UDP. So NTP, Network Time Protocol, DNS. Remember, this was a question in the practical exam. What are the TCP flags? Well, the TCP flags don't exist because it's UDP. And I think this is it for the networking, the transport layer. At the internet layer, we have the IP address, the internet protocol address, but we also sometimes use ICMP. Sometimes, because ICMP has a specific use. We're not using the transport layer or application layer here. We're just using, troubleshooting mechanism, some utilities available, like the ping utility. So when you use ping, usually you're using the ICMP protocol and you're sending an echo request to your target. If the target is active and there is not blocked by a firewall, you get an echo reply. There are multiple tools available for us. I'm not going to cover the tools at this point. And I think we do understand ping by now, so I'm not going to cover it as well. You can ping yourself, the loopback address. You can ping the gateway. You can ping another computer. Traceroute is used to to discover the path between yourself and the target. So it's between two hosts, and you can see how many hops away from you is the target. And Traceroute uses a feature in ICMP called time to live, or TTL. Again, it's something that I explained and I'm not gonna do in this recap. IP addressing, we have IPv4, which is a 32-bit addressing. So it has 4 octets or 4 bytes, 8 bits each. And the decimal representation is something like 10.10.10.10 or 192.168.44.12. So 4 placeholders, 4 bytes separated by a dot notation. The IP version 6 allows more security and definitely a lot more addresses because it has 128 bits. So 2 to the 128 bit is a very large number that we will not run out of. When we communicate, we either communicate specifically with a single target, single host. It is called unicast from this IP address to that IP address, or we do it to everybody on the network. This is called a broadcast. So from my IP address to all IP addresses on the network. So this is, for example, when we do ARP resolution, when we do a scan of a network, we're trying to talk to everybody on the network. And then finally, multicast is a specific group within that network. This is the decimal notation of IP version 4, but of course if it's binary then it would be 8 bits. So this would be the value of 192, this would be the value of 168, and so on. And basically the IP address has version 4. Here we have a section for the network and a section for the host, and I will show you very quickly. So let me just go to that. NATing is the translation of private to public IP addresses. So for example, the public IP address of your router at your house is something outward facing, public. That means anybody who's scanning the internet can discover that IP address. However, the internal IP addresses in your house, usually they start with 192. They're private IP addresses, class C IP addresses. NATing allows the translation. So this is what I talked about. So we will be, in our course, you're responsible to know the 3 classes. A, where 8 bits are dedicated for the networks, 0 is reserved, so 7 bits here, leaving us with 24 bits for the host. So 2 to the power 24 is something that probably in the 16 million IP addresses for computers or hosts. Class B, 10 is reserved, so let's say 2 bytes for network, 10 is reserved, leaving 16 bits for the host. So in a class B network, you have 2 to the power 16, which is 65,536 hosts available. And finally, in a class C network that we see at our homes, for example, 110 is reserved out of the 24 bits for the network, leaving us with 8 bits for the host. 2 to the power 8 is 256. So if you remember in our labs, when we use Nmap to scan our network, it tells you, the report tells you, I scanned 256 hosts because it's a class C network. The way that we represent the classes is basically to say slash then how many bits for the network. So if 8 bits for class A, then it's slash 8, 16 for class B is slash 16, 24 for class C, then it's slash 24. Remember that, please. Also remember the ranges. So class A is from 0 to 127.255.255.255. Class B is from the next, which is 128.000 to 191.255.255.255. And then the next is class C, which is 192, and so on. So basically remember that, because when you see an IP address in the exam, you need to make a decision what class it is, so that in your command you say, for example, slash 8, slash 16, or slash 24. IP version 6 has 128 bits, 64 are the prefixes, and 64 bits represent the interface ID. And this is it for IP version 6. We didn't cover it in details in our course. I think I'm gonna stop and call this part 1 of the revision. I will continue with the malware chapter in part 2.